circuits. So this is the UJT application as UJT Relaxation Oscillator. So we are going to see what is the application of UJT in relaxation oscillator. So it is called relaxation oscillator because most of the time the device will be in off. For a very small amount of time the device is going to be on. So it is called as relaxation oscillator. It is relaxing for most of the time, or I can say it is off for most of the time. Only when a trigger pulse is given, the device will be on for a very short duration of time. And see here what I am connecting. So I'm taking an UJT. I'm connecting external resistance R2 and R1. I'm connecting RE and CE. Across the emitter, I'm connecting resistance and capacitance. And I'm measuring the voltage VB1 and VB2, and I'm taking the output from the emitter. So if this circuit is designed with proper values of RE and CE, what they are saying is this circuit will give out sawtooth waveform. So this is the output of the circuit when you take from the emitter. And we'll see the working. So the relaxation oscillator is a common term used for generating sawtooth waveform. So I'm going to construct a relaxation oscillator using UJT, which is going to have capacitor CE and RE and the supply voltage VBB. So whenever you have a resistance and capacitor RE and CE, you know it is going to charge and discharge. And this RE and CE are going to charge, the capacitance CE will charge through RE from VBB. So this is the path through which the capacitor will charge. The capacitor will charge through RE from the supply voltage VBB. Okay, see here, you know that capacitor charging and discharging is exponential in nature. So as soon as you connect this circuit, the capacitor will charge exponentially. So the capacitor will slowly charge towards VBB. So it will charge towards till the emitter voltage reaches the peak voltage VP. When the emitter voltage reaches the peak voltage VP, your UJT is going to start conducting and the current is going to flow through the device. So when such a case, the capacitor will be discharging like this. The capacitor will be discharging like this. Whatever charge the capacitor has stored till the peak point will be discharged through the device as a current. So you see here, you have charging and you have discharging very quickly. You have charging and you have discharging very quickly, and this discharge will happen till the voltage at the emitter becomes less than the peak voltage. When the voltage becomes less than the peak voltage, again this capacitor is going to charge. So in this way, this action is going to be completely repetitive. So when the peak point is reached, it provides negative resistance, so the capacitance will start discharging. As the capacitor voltage reaches zero, the device goes to cut off. Again, the capacitor starts charging. So the charging and discharging of capacitor frequently will give rise to what waveform is going to be the sawtooth waveform across the emitter. So when you connect the output of emitter to a oscilloscope or any other device, you can see a sawtooth waveform coming out from the device. And what is the unique feature of the sawtooth waveform is the discharging portion will be very quick. The charging portion will take a longer amount of time. So charging will start from the valley point and it will go till the peak point. So from peak point to valley point, again it will discharge. So this process repeats continuously until a perfect sawtooth waveform is produced from the device. Sawtooth waveform means this is the ideal sawtooth waveform, but practically you will have sawtooth waveform like this. So you cannot have a sharp edges, right? So practically the sawtooth waveform will have charging and a very small discharging. But here charging is very large, discharging time is very small. Okay, so the cycle keeps on repeating. So I'll explain once again, please understand. So whenever I'm going to connect the circuit, this capacitor will charge from the VBB through the resistance RE, and the capacitor voltage is given across emitter. So when till this charging will happen till the voltage across emitter becomes equal to VP. Once the voltage across emitter becomes equal to VP, the device is turned on and the diode becomes forward bias. So whatever charge the capacitor has acquired, it will discharge through this way till the device reaches valley point. When the device reaches valley point again, the capacitor starts charging. and this process repeats continuously, giving rise to what is called as a sawtooth waveform. That is what is given. Cycle is repeated continuously, generating a sawtooth waveform across CE. So I am adding external resistance R1 and R2. I am adding external resistance R1 and R2 with B1 and B2, which is going to provide the spike waveform. So when the UJT is going to fire, sudden surge of current will flow through B1, causing a drop across B1. So you know that when the device is going to be in on state, huge amount of current is going to flow through the device. So to control the amount of current flowing through B1 and B2, we are going to have the resistance in series with the device R1 and R2. R2 is present at the B2 terminal. R1 is present at the B1 terminal. Okay, so at times of falling the cost to, so that's why to control the amount of current or to provide the device from getting damaged, we have two resistances R1 and R2 connected across the device in the terminals B1 and B2. So by changing the value of capacitance or by changing the value of resistance, the frequency of the desired output waveform can be got, and it will clearly depend on RE and CE. So you know any periodic waveform is generated, you can find what is the time period and frequency. Time period is time taken to complete one full cycle. So this is one full cycle. If you see in this diagram, one full cycle is going to start from T2 and it is going to complete till T4. This is one full cycle, charging and discharging completely. So you can measure time difference T equal to T4 minus T2, and frequency is going to be 1 by time. So you can measure the frequency of oscillation. Okay, so that is given here. You know the capacitance, usually the charging and discharging waveform is exponential. So the capacitance charging waveform is given by Vc equal to Vbb into 1 minus e power minus t by Re into Ce. So this formula is the general charging formula for a capacitor. So you need not derive this at this point. Vbb is the voltage through which the capacitor is going to charge, and 1 minus e power minus t by Re into Ce. So this is the voltage across the capacitor at any point of time. So the capacitor will charge till Vc equal to Vp. So substitute Vc equal to Vp, and you know Vp equal to eta into Vbb. It is the voltage across the terminal B1. So I can cancel out this VBB. So I'll get eta equal to 1 minus e power minus t by Re into Ce. So take a e power minus t by Re Ce on one side. So it is 1 minus eta. So you take natural logarithm on both sides. If you take natural logarithm, you get t is equal to Re Ce. This log to the base e. See, generally in calculators, you will have log and ln. So log is to the base 10. Okay, and ln means it is natural logarithm. Ln means it is log to the base e. So whenever you have exponential, if you want to eliminate that, you have to take natural logarithm. So if you take natural logarithm on both sides, you will get t is equal to RECE ln 1 by 1 minus eta. If you convert log into ln, you have to multiply by 2.303. So t is equal to 2.303 RECE. See here, log to the base e is becoming log to the base 10. So if you're converting log to the base e to log to the base 10, you have to multiply by 2.303. So 2.303 RECE log 1 by 1 minus eta. So this is the time period, capital T. So if frequency is 1 by T, so 1 by 2.303 RECE log 1 by 1 minus eta. So this is going to be the frequency of oscillation of the sawtooth waveform, which is got from the UJT relaxation oscillator. This is a very small derivation. The basis of derivation is from the discharging formula of the capacitor. So from the charging formula of the capacitor, we can find what is the frequency of oscillation of the sawtooth waveform, which is produced by the UJT relaxation oscillator. Okay, it is produced by the UJT relaxation oscillator. So any doubts or queries you have?